Hey guys, welcome back to my YouTube channel. Today we're learning about Pythagoras theories.
Alright, so please have your books out. I'm going to teach you about Pythagoras' theorem. Your workbooks will be enough for today. So, do I have enough pages? Yes, we do. What is this? There we go. Alright, so your heading is Pythagoras' theorem. So, actually, this should go in your bound reference, okay? Well, just put it in your workbook for today if you don't have your bound reference. Okay. What kind of angle is that here? Right angle. How many degrees are in a right angle? Good. That was one of the values of doing that sheet just now. Okay. I'm going to make a definition. So the hypotenuse is the longest side in a right-angled triangle. So, which one is the hypotenuse here? Is it C? Is it A? Or is it B? Okay, so we are going to get there. If we don't know Pythagoras' theorem yet, how could we decide which one was the longest side in this triangle?
Well, because the largest angle there is 90.
The largest angle. Very good, okay? So the other two angles are smaller. So you only, that's your hint, basically. Look at the angle, look at the side length that is facing outwards from the right angle. That's the hypotenuse. So I'm going to write that down. It faces outwards. So in this diagram, C is the length of the hypotenuse. All right. We need one more thing. We need the actual formula. So some of you already know the formula. This is the formula. That's the formula, okay? Now, I want you to note two things. This only works for right-angled triangles. You cannot use this for other triangles. You will break the universe if you do that. Okay? It's just a joke. All right, and the other thing is, C must be the hypotenuse.
So C is always just the longest side?
Yeah. Okay? So, if you put C in the wrong place, your calculation will be garbage because you'll get the wrong answer. All right? So you must set up A, B, and C so that the third side C is the hypotenuse, the longest side. Yes. Okay?
What's the last word?
Hypotenuse. Yep. Hypotenuse. News. I don't really know where that word came from. It seems like a very complicated term.
Where did any word come from?
Maybe ask your English teacher the etymology of hypotenuse and see what they have to say. Ask Mrs. Evans, because she teaches maths and English. She might know. All right, everyone got this down? All right, this is the most important thing to pack in your bag for this trip through this topic. Okay, basically, all we're going to do is use this formula again and again for the next couple of weeks. So if you've got this, you're pretty much good to go. The rest is just me giving you some examples.
Mr. Chu, I know what A2 plus B2 is.
What does it equal? Good. All right, so I'll get you started with some examples now. Yes, please get this down. It's up to you. Yeah, we're going to do this together as a class. Okay. Now, is there something that I should add to the diagrams to make it clearer? Can anyone?
Yeah, the answer.
The right angle. If it's not a right angle, it's not clear if I can use Pythagoras' theorem. Okay?
How do you work it out with a non-right angle?
I can teach you that if you want.
No, not now.
Not now. Maybe next week. You'll need to know some trigonometry though to do it, so I'll have to teach you that. Did you use the slides that I gave you? Yeah. Okay. All right. So remember, if you've forgotten already, because I know we do forget things, this is the picture, okay? A squared plus B squared equals C squared. So our first step in every question is to write down an equation using Pythagoras' theorem. So just this once, you can skip this after today, but just this once, I'm going to say a squared plus b squared equals c squared. And now I need to fill in the numbers for a, b, and c. So does anyone have a suggestion for what I could use? So the goal is to find x. Yep.
25 for the first one. X is 25.
All right.
It's 5 squared.
Is this line okay? Are people all right with this? Okay, so all I've done is I've said 4 is A, I've said 3 is B, and I've said X is C. No, but you've got to have C. C has to be X here. You can swap the 3 into 4, but you can't use. Well, see, my goal here is to find an unknown side. See, I don't know how long this third side is. That's why I've called it X. I don't want to find it. So if I have all 3 sides, there's nothing to do. Make sense? Okay. Okay. Isn't it good that we've done a topic on indices? Because we know what this means now. Okay, are we done? Whenever I ask that question, it's usually no. Why aren't we finished?
X equals 5 squared.
Because they're always behind you.
So, if I know x squared, to get x, I need to take what's called the square root. The square root is like the opposite of squaring. So the calculator will do this step for us. Okay? We don't need to do square roots by hand. Thank goodness. And if you do that, you'll find that it's 5. Okay? And then I'm done. Now I've found the unknown side length x. It is 5. Make sure you've got this down. All right. And then you're done because you found the unknown side length. Okay? Okay, I'm going to call on people now, so get ready. Yes? I don't know how to answer that. Also, I think hard work matters more than intelligence. All right, year 9s listening up. This might be the last example we do before I let you go. We'll see. So, Mia, I'm going to call on you. So, I've just written down the Pythagoras' theorem, which is a squared plus b squared equals c squared. Shh. And I would like some numbers to replace some of those letters. So do you have any ideas what we might do here? Great. Well done. Okay, Reese, what should we do at this step here? Find the square root is correct. Yep. So it turns out that 25 and 169 are perfect squares. So if you have them memorized, that's great. But we're now going to do an example. So we will do one more where the answer will involve decimals. Okay? So just let me know when you finish writing this one down, and then we'll do one more example, and then I'll let you get started on 7b. So who's still writing? Okay, take your time. No, what I mean is don't feel that I'm rushing you. Yes. Mm-hmm. You need lots of maths to be an engineer.
Is this like extension level?
No, everyone's doing this.
So when we get on
The extension level will require you to combine multiple calculations with multiple triangles. Okay? All right, last one, folks. So I'll do this one for you. Okay. Folks listening. All right. So I'll do this one with you. So I'm just going to chuck the numbers in. Okay. And here we actually run into a bit of a problem here because 12 squared is 144, 13 squared is 169. I don't have a number that's a whole number that solves that for me. So Turns out, if we try to do this, we actually create a new type of number called an irrational number, which can't be written as a fraction. And the decimal representation goes on forever.
Is that 49 or 44?
Neither.
What are you talking about? No. I'm talking about above 149 equals c squared.
Yeah, that's 49. 49. Yeah. Okay, so at this step, you must use a calculator, unless you're some supercomputer that can do square roots in your head to arbitrary precision. You'll need a calculator, and I do because all right. So this is actually a Python prompt here that I'm using. Yeah. All right. That's Pythagoras' theorem. 7b, all we do is change this to the pronumeral and we give it the hypotenuse. So this is actually a lot easier than indices. We have a picture for every question now. Okay? Huh? Yes, but I can leave it on the screen. All right. So all of you can now start on exercise 7b. Use the work program. I hope it's a bit clearer this time. I did this work program. I hope you'll find it better than the one from last time. All right. Get started.
Can I go get my book, please?
Yes.